Hi, everybody. All right, so thanks for tuning in today. The plan is that we're going to go over how to solve when you have a logarithmic equation. Okay, so that's something when you have the log, the log, or the ln, natural log, in the problem. But before we do that, we're going to go over what we know about logarithms so far. Okay, so you can get out your notes if you'd like and write some of this first stuff down, but definitely you want to write down all the example problems. Okay, so the first thing to remind you of is we have these properties of logarithms. Okay, so we have this first property where you have a product. So if you have two values inside the logarithm, that's called that location, by the way, that's the argument of the logarithm, okay? So inside the argument, if the two terms are multiplied, so that's product, then that converts into addition, all right? You add those two logarithms together. And then if you have division inside that same location, and by the way, a fraction counts as division, that turns into subtraction. And then the last thing that could happen is you could have an exponent, and I'm going to highlight that. You could have an exponent or a power. Okay, and that power gets relocated out in front of your logarithm. Okay, so those are the three properties that we've been working with, and they're going to be really helpful in solving logarithmic equations today in different instances. The other thing that we need to remember is that you can convert a logarithm to an exponential function, okay, because they are inverses of one another, okay, and you can actually do that pretty seamlessly, okay. So if you look at this little review concept right here, over here on the left-hand side, this is a log. It's very obviously a log because it has the log at the beginning. Okay, and then this part over here that I'm highlighting in blue, that's an exponential. Okay, so log exponential. And if you notice, they have the same exact variables in them. So you can convert something that says log base b, and then that base will turn into the first thing you write in an exponential. Log base b of y, that y ends up being what you're equal to. And then log base b of y equals x, well, that becomes your exponent. And that's because really, at the end of the day, a logarithm that means equals an exponent. Okay, that's what it is, that's what it represents. So the log will always be equal to the exponent that you should write in your exponential equation. Okay, so that was a review of what we've talked about previously. So now we're going to get into some new stuff, okay? So, I should say, sorry. I wanted to make sure we had an example of all of that so that you know what I'm talking about. So to review all of that, let's quickly go through what it means to condense and then convert, okay? So if you look at this example that I've given you, the first thing we're going to do is we're just going to focus on this left-hand side, and we're going to use our properties to condense. Okay, that's what we're going to do. So if I take a look at this problem, it would appear that I have 3 times the log of x minus the log of 5. Well, this 3 could be relocated so that it is an exponent, right? That's one of those properties. And then if I have subtraction, that subtraction really means that I can divide these things. So this subtraction really means that I can rewrite this first thing in the argument, x to the 5th, and I can divide it by 5. And now that has the whole time been equal to 1. So how would I convert this to an exponential because now it's been condensed. This green part right here, that is condensed. How would I convert? I want to change my highlighter color. How would I convert this to an exponential? Well, let me rewrite this equation. And I'm going to rewrite this equation up top, okay? We've got, according to our top part there, it says the log base b of y equals x could be converted to b to the x equals y. And what do we have? We have the log of x to the 5th over 5 equals 1. Oh my goodness, I'm so sorry. I just noticed something. I was so focused on that 5. Hopefully some of you caught it. This 3 right here, that's my exponent. X to the 3rd over 5. Okay, so as I was saying, we've got this logarithmic equation. We want to convert it. Okay, well, first off, we need a base. What's the base when you don't see a base? It's the common log, which is 10. Okay, so when I go to convert, the first thing I write is my base. I start with that base. So we're going to go 10. And then the second thing I need to find is my x. Well, when I'm in my log form, that's on the right-hand side. That's what I'm equal to. So equal to x. So this is the second thing I need to look for. That means I'm equal to 1. Okay, so 10 to the 1st equals, all right, so I've done the b to the x part. Now I just need to figure out what y would be. Well, y is whatever was in the parentheses. So in that case, it's this whole fraction, x to the 3rd over 5. So this equation right here that I'm highlighting underneath, that is our converted exponential equation. 10 to the 1st equals x cubed divided by 5. Now we're not going to solve that yet because we're going to save it for this next part of our lesson. All right, so now we're really going to dive in. We're going to use that skill, converting to an exponential in order to solve. Okay, so one last time, I'm going to write this down. We've got the log base b of y equals x. Convert would be b to the x equals y. Okay, so as I just said, the first thing you want to do is you want to find your base. Okay, you want to find your base. So I found my base. It is this subscript of 2. And then I want to find my x value. I want to find my exponent. Well, in my log, if the log is in there, the x value is on the right-hand side. So that means my exponent is 3. B to the x, so I did that right-hand side. Now I just need to know what y equals, and y is inside the parentheses. So y has to be 5x minus 17. Okay, so what I just did from here to here, how did I get from the problem to this first step? I converted to b to the x equals y. That's the exponential form. And now I'm just going to do some math. I'm going to see what I know. Let's see, 2 to the 3rd, that's 8. And if I want to solve this, I want to get x by itself. So I'm going to add 17 to both sides because that'll get rid of it on the right-hand side. And that'll give me 25 equals 5x. And then I'll divide both sides by 5 so that I get x all by itself. So then x is going to equal 5. And then just to check my work, I'm going to take the log base 2 of 5x, which would be 25, minus 17, and set it equal to 3, and see if that's true. The log base 2 of 8, is that 3? Well, 8's 2 to the 3rd, so yes, that works. Okay, so second example problem. We're going to use the same skill, but we are going to have to include one additional situation. We have an addition symbol in between here, which means we need to multiply whatever is inside the logarithms first. So we're going to convert this to the log of 2x times x minus 5. before we convert this to an exponential. So now, as a reminder, if you don't see a base, the base is 10. It's kind of like how if you don't see an exponent, the exponent's 1. These are just some rules we need to know. So then if I convert, I'm going to take 10, find my exponent, it's 2, and set it equal to 2x times x minus 5. Why all of that stuff? Because that's what's inside the logarithm, okay? And then I'm going to do some multiplying. So 10 squared is 100. 2x times x is 2x squared, and negative 10x. Okay, so it looks like I need to factor. So I'm going to set this equal to 0. 2x squared minus 10x minus 100. Everything's even, so I'm going to divide my whole equation by 2. So 0 is going to be equal to x squared minus 5x minus 50. All right, so now I need to figure out some factors of x, okay? So I'm going to give you a second to think on that. All right, now, hopefully you figured out that 50 is 10 times 5, and you could make it positive 5 and negative 10, and that will end up adding up to negative 5. Okay, so with that, we separate our factors, we solve them, and then before we officially figure out our answer, we double check. If we plug these in, do they make a true statement? So can I plug in negative 5? Can I take the log of a negative number? The answer is no. So that value is extraneous. We've talked about extraneous before during our radicals unit. Can I put in 10? 10 will be positive. So yes, that answer is going to work out just fine. Okay, so that's one method. That's definitely as hard as the problem is going to get around here. So then method number 2 is when you've got the two arguments, when you're going to set the two arguments equal to one another. So basically, there's a rule that if things are equal, and if some part of them is the same on both sides, then what's inside or what's left that's different has to be equal. What do I mean by that? I mean, if you had a fraction, like let's say you had x over 10 equals 7 over 10. The 10s are the same. So we already know those are the same. So then the x that's up here has to be equal to 7, because that's the part that looks different. But if the things are equal, then they have to be equal. So what am I saying? I'm saying you have a natural log of something equal to the natural log of a completely different expression. But if they're both natural logs, same type of logarithm, like if the outsides are the same, equal, then the insides have to be equal too. So you can basically just drop off the natural logs and just say, okay, if these are supposed to be equal, it's because there's this equal sign here. If these expressions are supposed to be equal, then you just set what's inside the parentheses equal, and you solve that. So we would add 7 to both sides. You could do this problem a couple different ways. It's really up to you. You'd arrive at the same answer no matter what. And I would subtract x. I'm doing it this way so that everything stays positive while I'm solving. I like to keep it positive if I can. So then x is going to equal 4. And then you just want to think about it for a second. If I plug in 4, is that going to give me positive things? Yes. Yes, it is. All right. So that's what happens when you set your two parts equal to one another. Okay, so there are a couple of practice problems that I'd like you to do on the back. I'm going to try one of them for you right here, right now. So we're going to try problem number 3. Okay, so log base 3 of 3x squared plus 3. Whenever you see plus, that means really what you need to do is multiply. So we're going to take 3x squared and we're going to multiply it by 3 and set it equal to 2. And then I've got a log equal to a number, so I'm going to convert. So this is going to turn into 3 squared equals 3 times 3x squared. So here I converted. All right, and then 3 squared is 9. 3 times 3, also 9x squared. So I can divide both sides by 9, so I get 1 equals x squared. I can take the square root of both sides. X equals plus or minus 1. Look at that. All right, now I would love it very much if you finished the other 3 problems along with this error analysis.